This is Josh White with JW Math Tutoring, and today's video is going to focus on the solutions to the October 2022 QAS SAT Math Section 4, the calculator section. Now, please keep in mind that I like to show as many possible solutions for each problem. Therefore, my videos may be a bit longer and more detailed than some of the other explanation videos that you might find out there. And they also might run past the time limits, for the various sections of each test. Also, if you haven't done so, please do check out the solutions to the no calculator section from this test, which I just posted a couple days ago. So let's go ahead and get right into it.
But life is a dream that calculus could never predict.
Okay, so just before I get started on the calculator section from the October 2022 SAT QAS, I just want to mention two things very quickly. The first is, of course, if you like this video and my other videos, please click the thumbs up on them, subscribe to the channel, sign up for notifications. And the second is, there was a recreation of this QAS that was just released yesterday, October 22nd, on the SAT subreddit, over on Reddit. However, the original version of that recreation of that PDF file had multiple typos in the math section. I think someone went through and looked at it and found a total of 5 typos or errors among the no calculator and the calculator sections. So just be aware of that. The version that I'm demonstrating on the screen here and the link that I'm going to have in the description for this is for the what I call the web version, where it's just straight screenshots of the questions, from the College Board's website. So there's no typos, there's no errors, there shouldn't be any issues. So just be aware of that. If you do, download the other version and are looking at that recreation, which basically is formatted to look like the actual SAT looks like, there are multiple questions which do have typos currently with them. I mean, they may be fixed in the future, but for right now, they are not. Okay, so starting off, question number 1. This is a fairly straightforward question. You're just evaluating this function for an x value of 8. So that just means we're going to plug in 8 for x, and then go ahead, do order of operations, multiply out 17 times 8, and add 13 to it. You can do it all on the calculator. The correct answer is just going to be letter D, 149. Now, moving on to question 2. Here you have a linear inequality. So it's where you graph a line and then you shade one side of the line. And the point that is going to be part of the solutions to this inequality is basically point A. It's 5, 0. And you can just look at the graph and see which point is actually in the shading. Here's A. B is at 0, 5. So that's wrong. C is at negative 5, 0, which is over here. Wrong. D is at 0, negative 5. Also wrong. So correct answer is letter A, 5, 0. For the next question, question 3. For this question, so they have an original painting, which is 21 inches by 30 inches, but an artist is going to create, a larger version of that. And so to keep the same proportions, you're going to have to multiply both sides by some scale factor or some value. And that's what the x is here. Okay, x is basically the scale factor, if you want to think about it in geometry terms, that you're multiplying each side by so that the proportions between the length and the width stay the same. So that's why the correct answer is letter C. Just so you know, you might think that it's going to be letter D, but in order for it to be letter D, it would technically have to be 21 times 30 and then just times x one time, not 2 times like it is in this example. Next up, question 4, we have a geometry question here. So this one, there are 2 different ways you could do it, but they both essentially end up being kind of the same, which I'll show you. So the first is, if you remember the exterior angle theorem from geometry, that basically tells us that an exterior angle, which in this case is y, is equal to the sum of its 2 remote interior angles, which in this case would be the 90-degree angle up here and this other angle over here, angle C. So if you sum those up, you get 130 degrees. Correct answer is going to be letter C. Now, if you did not remember that, then you could kind of do it the long way, which is to recognize that x plus 40 plus 90, which makes up the triangle BAC, has to add up to 180. Then you go ahead and solve that, and you'll find that x equals 50 degrees. And then you just realize that x plus y, or 50 plus y, adds up to 180 because it's a straight line. Therefore, y is going to equal 130 degrees. Again, it's the same answer. It's just like a different way of thinking about it. It's a little bit longer because it's a couple more steps, but you know, really not that much more time. Moving on now, questions 5 and 6 both deal with the same information, the paragraph that you see here. So in this question, basically what's going on is you have a Dakota who's charging charging $10 per hour. So let's say 10x, x is the number of hours, and then plus $5. Okay, so an hourly rate times the number of hours, and then plus the flat fee. Then you have Alex, who's charging $8 per hour, so 8 times x, and then plus a fee of $4 for child, so I'll just call that 4C. Now we set them equal to each other because it tells us if they charge the same total amount for their jobs. So that's why I set them equal. And now the other thing we have to keep in mind is that they're babysitting each babysitting 4 children. Therefore, the total amount that Alex will charge is not going to be 4 times C. It's actually going to be 16, okay, because it's 4 times the number of children. So now you can solve this equation, and you can get x. So let's see, I get 2x equal to, subtract 5, cancel out, 11, divide by 2. X is going to equal 5.5. Correct answer is going to be letter C. Now, just to show you, an alternate way you could do this is you could back solve this. So you could go through the answer choices and just, to show you how I do it on the calculator, you could say, okay, Dakota charges $10 per hour, and let's take answer choice A. It's 2 hours, and then plus $5. So Dakota would charge $25 for answer choice A. Alex would charge $8 an hour times the 2 hours, and then plus, and now here's what you have to remember, it's going to be $16 because 4 children, $4 per child. So Alex would charge $32. So they are not equal, so that would tell you answer choice A is wrong. And then you could go down and check B. That would be wrong. Eventually you would get to C, and that would be correct. Now for question 6, again, it's the same situation, but here we have some graphs. And they're basically asking which graph shows kind of like Dakota's, like, say, line, if you're going to write it out as a linear relationship. So we already said it was 10x plus 5, so you think about it. Basically, we're saying which of these graphs is equal to y equals 10x plus 5. So notice the y-intercept is 5. A is out. D is out because it doesn't start at 5, it starts at 10. So now we're down to B and C. So which of those has a slope of 10 or 10 over 1? I will zoom in here just to make it nice and large on the screen. So if I start here, I go right 1, and I go up 5. So it looks like I go up 10. So it looks like the slope for this one is 10 over 1. And then in C, if I start here, I go right 1, and I go up 5, 10. It's 15 total units. I start at 5, I end at 20. So the slope for this one is 15 over 1. That's wrong. Correct answer is going to be letter B. Also, you could also graph this line on a calculator and then see which, graph or whatever matches the ones you're given here, but you shouldn't need to do that for this problem. Next up, we have another question related to lines. So we know that this given line has a slope of -3, and it has an x-intercept of 9/2, 0. What is its y-intercept? So all we have to do is go to y equals mx plus b, slope-intercept form of a line, and now just plug in the slope, plug in the x value from the point we're given, which happens to be the x-intercept, plug in its y value, and now solve for b. So negative 3 times 9 halves, you can do that on a calculator. If you're not comfortable with fraction multiplication, it's going to be negative 27 halves. And then hopefully now you see you just add this to the other side. So the y-intercept will be 27 halves, or of course, as you write as a point, 0, comma 27 halves. Also, if you were looking at the answer choices, you should have been able to eliminate A and C right away because those do not have a 0 for an x value, which is a requirement for a y-intercept. Always has an x value of 0. All right, next up we have question number 8. Here you have a table. It's kind of small, but we can zoom in just to make the numbers a little bit larger. All right, and it just asks us what's the range. So we just have to take the largest number, which is the 72.2, subtract from that the smallest number, which is a 3.7. If you do that, you will get 68.5. These are in thousands of acres, but the answers are also in thousands of acres, so don't have to worry about the extra decimals. Letter C is correct, 68.5, and that's it. Now, number 9 deals with the same table. Zoom in just to get the values a little bit larger there on the screen. Also, let me just shrink the calculator so we can see the whole question. All right, so now what they're asking for is they're saying we get rid of the New River Gorge. And then what is the new mean compared to the original mean? So okay, these first three numbers are all fairly small and close to each other, 3.7, 4.3, 11.6. Then you have an extremely large number, 72.2. So if you take away that 72.2, that very large number, the mean is going to go down. It's going to decrease. So the correct answer for this one is going to be letter B. However, if you weren't sure, you could just go ahead and calculate it on the calculator. So you could add up the 4 values to get the original mean and then divide it by 4. If you do that, it's 91.8 divided by 4, and so it's 22.95. And then the new mean, which would now be just divided by 3, is 19.6, and therefore it comes out to 6.53. So you can clearly see now that the mean amount of area for the 3 remaining parks has gone down. All right, next up, question number 10, another question dealing with lines. So they give us this equation, and they basically just want to know which graph, which of these graphs represents this line. So hopefully you notice this line has a positive slope, and it also has a negative y-intercept. So first of all, eliminate C, eliminate D. Those lines have negative slopes. They do not have positive slopes. Okay? And now all we have to do is basically pick another point and then see which, we figure the x value and the y value and see, well, which of those, that point is on which of the 2 remaining answer choices, A or B. So I'm going to pick 100 because I can easily multiply that. I just move the decimal over. I'm basically plugging in 100 for x, and so I'm going to see what my point I get is, 100 comma what. So I get 560 minus 324. If you do that, let's see, we can just do it on the calculator. Looks like it should be 236, I believe. So if I do 560 minus 324, okay, I get 236, so that checks. Okay, so now when I go to 100 on the graph, the point I'm looking for is 100 comma 236. So now I go to 100 on the graph. Here, this one looks like it is between 200 and 250, so that could be 236. However, for B, it's like way up here between 720 and 920. That's clearly wrong. It's going to be answer choice A. Looking at question 11, here we have a question covers an area you see a lot, which deals with predicted versus actual values. So you're given, a bunch of points on here, scatter plot, and then there's a line of best fit. And they want to know for how many points is the line of best fit greater than, or in other words, predicted greater than actual. What this means is we want the points, the dots, which are below the line. Okay? Because the predicted is the line, and we want the actual to be less than that. So we want the y values which are below the line. There are going to be 4 of them. 1 down here, 2, 3, 4. So the correct answer for this one is going to be just letter C, 4. Now, in question number 12, here again another question dealing with information related to lines. So the slope of this given line is going to be 2. The slope of line J, which will be perpendicular to that, will be its opposite reciprocal. So I'll just say the slope of the perpendicular line is going to be the opposite reciprocal of positive 2, which is negative 1/2. So the correct answer is just letter A, negative 1/2. Nothing else to do. For question number 13, this is also, the information here also relates to 14, the next question as well. So they give you a lot of information initially, but to actually answer this question, all you need is one piece of information, which is the 250 million people. So they tell you the adult population is 77% of the total. What's the total population? Two different ways you could set this up and solve it. You could either say, okay, 250 million, and I'm just going to do it just in terms, I'm going to ignore the millions right now, is, or was, 77%, which is 0.77, of X, the total adult population. And then you just divide that by 0.77, and you come out with approximately 324.6 million. So the closest one is going to be letter C, 320 million. An alternate way to do this one would be using proportions. So I would basically set it up as like 250 million, which is just adults, out of X, which is the total, is equal to 77% out of 100. And then you just cross multiply, you get 77x equals basically 25,000. And then you divide that and you get the exact same value, 324.6, which rounds to 320 million. Now, for the next question, 14, again, you have the same given information. Now I want to know what fraction had access to our more social media websites, and we're doing adult internet users only. So that means our denominator for the total number of outcomes is 160 million. And for the number of favorable outcomes, that's the number of people that access two or more social media websites, so that's just the 52.8. So this fraction now has to be reduced down or simplified. It comes out to 0.33, but notice all the answers are in fraction form, not decimal form. So we can just turn this into a fraction. I mean, if you don't recognize it, it's basically 33 out of 100. You could, you move the decimal over twice because it's really like this over 1. Or if you have, again, a graphing calculator, like say a TI-84 or any of the newer TI graphing calculator models, say we could do this. So you could type in the 52.8. Actually, let's see. I'm going to type it in as a fraction and see if that will reduce it for us first. So I went to the fraction menu and typed it in vertically. Okay, it doesn't. It gives us a decimal. So now what we have to do is just go to math, then go to fraction, and hit enter. Okay, 33 over 100, and that's how we would get it. So correct answer is just going to be letter B. Now, looking at question number 15, for this one, this is one of those questions they like to give you where they give you some equation and then they ask for a value of some expression, not just say for x or y or whatever. And typically, the expression that they give you is like supposed to be something that you can find with just like, usually one step, like adding two things together, or subtracting two things or whatever. So I'll show you how you could do it using that method first, and then I'll show you just solving it all out for x later. So technically what you could do here is you could subtract 9 times x plus 9 on both sides. And then on the left side, you have 10 of x plus 9s, and then you subtract 9 of them, so you're left with 1x plus 9. On the right side, all that you're left with is 25. So what does x plus 9 equal? Well, 25. Correct answer is C. Now, if you don't recognize that or don't quite follow that, that's perfectly fine. Then I would just go ahead and distribute the left, and I would distribute the right, and then I would go ahead and combine like terms. First, I'm going to subtract over 9x here. So I'm going to get x plus 90 equals, what is it, 106. And then you can subtract 90. So x turns out to be 16. But remember, you're solving for x plus 9. So 16 plus 9 equals 25. Same answer. Really not that much longer than the first method. All right, the next question deals with basically a little bit of statistics knowledge. So it's basically asking about what would you do in order to get a smaller margin of error, and which would allow your study to be generalized to the entire like local population. So the answer for this is going to be D. Basically, whenever you have some type of study that you're doing, the larger that you make the sample in the study, the smaller that the margin of error becomes. So larger sample size, smaller margin of error. And the opposite of that is also true. Smaller sample size, larger margin of error. So that's just something you should memorize and commit to memory for these questions, that might come up on the SAT. Next up, question number 17. There's multiple ways you could think about this one. I will show you kind of first the theory behind it, and then I'll show you how you could just use picking numbers to solve it. So the ratio of the diameter circle to circumference is 1 to pi. So if you think about the formula, okay, circumference is equal to pi d, right? So, okay, the ratio of diameter to the circumference, right? It's just like this, d's cancel out. Okay, it's 1 to pi. So if the diameter gets multiplied by 3, how will the circumference change? So notice, if you just multiply the top by 3, then in order to keep the fraction equal, you have to multiply the bottom by 3 as well. Otherwise, the fraction would not be the same. So the correct answer is going to be letter C. It's going to be multiplied by 3 as well. And if you're not sure, here is just a brief example using picking numbers as to how you could get it. Let's say the diameter of your circle is 2. Okay? Then the circumference would be pi times 2, or 2 pi. Now let's multiply the diameter by 3, so it's 6. So the new circumference will be pi times 6, or 6 pi. I multiplied the diameter by 3. What happened to the circumference? It was also multiplied by 3. So this confirms again the correct answer is letter C. Again, that's the strategy of picking numbers where I picked a number for the diameter. I used that to calculate the circumference. Then I applied basically the information in the problem, which is, well, multiply the diameter by 3 and found the new circumference, and then looked at the change in the old circumference to the new value. All right, question number 18. This is not a difficult question, but it's just kind of a pain because you have a bunch of sides that you have to find the values for. So I'm going to zoom in just to make the picture a lot larger on the screen. Okay, so here are the values for all the missing sides. Okay, first of all, we know that across from this 2.5 is a 2.5. That means this has to be 2.5 as well. And therefore, that means that this 7 across the bottom, if you take away this 2.5 here, that gives you the value of this side, which is going to be 4.5. All right? So that's how you can find that side out. Now, to look at some of the others, basically, okay, so from here to here is 9, and from here to here is 8. That means the difference left over is 1, and so that 1 is basically going to be split evenly as zero point 0.5 here and zero point 0.5 here. I guess technically we don't know that, but since you know that together they add up to 1, it doesn't matter how you split them up, whether it's zero point 0.5 and zero point 0.5 or 0.75 and 0.25 or whatever. The takeaway is that the total of these two unknown sides is 1 when you add them together. Let me just look at my picture. That should be it. So now you're going to add up the following values. I'm going to start at the top and go clockwise. So we've got a 5, we've got a 9, finding the perimeters, we're adding up all the sides. We've got a 4.5, we've got a 2, we've got a 7, we've got another 2, we've got a zero point 0.5, we've got a 2.5. Now I've got to jump down. We've got an 8, we've got another 2.5, we've got a zero point 0.5. If you add all those numbers up together on the calculator, they are going to come out to 46. The correct answer is going to be letter D. Okay, again, kind of a pain to figure out these three unknown values and then just have to type all those numbers into the calculator, but the correct answer that you should get is going to be 46, letter D. All right, next up, question number 19. Here you have two tables of values. I'll zoom in just so they're a little larger on the screen. And you're asked to compare the mean and the standard deviation for both of them. So, first of all, notice that the first set goes from 0 to 9, whereas the second set goes from 4 to 13. So the mean of the second data set is going to be higher than the mean of the first data set. Now, I also know not only are the values higher, but also what you notice is that the frequencies match up perfectly. You know, it's one of this, one of these, two of these, three of these, six of these, 5, 4, 3, 3, 2. So the frequencies are identical. It's just that every value on Q is 4 more than the corresponding value in P. So the mean for Q will be greater than the mean for P, or in other words, C is greater than A, or if you rewrite it, A is less than C. So right off the bat, we can get rid of C, we can get rid of D. Now, what about the standard deviation values? So it turns out, because of what I just said about how the frequencies are identical among them, the standard deviation, which measures the spread of values relative to the mean, you know, relative to the average, because that spread is identical, the standard deviation for each of these are going to be equal. So the correct answer for this one is going to be B. In other words, if you plotted each of these out, just to show you real quick, it would look something like 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 3, 3, 2. Okay? Let's say that would be data set P, starting at 0, ending at 9. If you went ahead and did the same exact thing for data set Q, the dots would be in the exact same positions, it just they'd be starting at 4 and ending at 13. But the relative positions, the relative shape of all the dots would be identical. So that's why the standard deviations will be equal, and therefore it is answer choice B. Continuing now with problem number 20. This problem is basically sort of a geometry problem, I guess you could say, or really it's just more, or you could say it's more of an algebra problem because it deals with the slope between 2 points. But first thing you can notice is that this line, you have this line which is tangent, and then you have basically answer choices, which are which other points are on, this line. So the first two answer choices are not going to be on that line just by like a rough estimation or visual inspection. So for example, 0.5 would be like somewhere right around here. Okay, that's clearly not on the line, so we could eliminate that. B at 3.6 is going to be over 3 units and up 6 units. Again, clearly not on the line, so it's got to be one of these two answer choices right here. Now, the way we actually figure it out or calculate it is first find the slope between -1, 1 and this point 4, comma -3. The reason that we would want to do that is because once we know the slope of the line segment that connects those two, then we can find the slope of line T because we know line T is perpendicular to this other line segment that connects the center of the circle and 4, -3. Okay, so first thing I'm going to do is just go ahead and find the slope between these 2 points. Now, you could plug them into the slope formula, so you could do -3 minus 1. You could also do then 4 minus -1 in the denominator, so we get -4/5. So the slope of this line segment is -4/5. Now, the piece of knowledge from geometry that you need to know is that whenever you have a line which is tangent to a circle, if you draw the radius, i.e. a line segment, from the center of the circle to that point of tangency, it will always form a right angle, i.e. the radius and the tangent line are perpendicular. That means the slope of line T will end up being the opposite reciprocal of the slope of this line segment I just calculated. So again, so for the slope of line T, it's just going to be the opposite of the reciprocal. So we'll take the 5/4 and flip it. Therefore, the slope of line T is just going to be positive 5/4. One other thing just to point out too, you technically don't have to use the slope formula since they've already given you the graph here. You could also get the slope by counting. So for example, if I started, let me just erase some of this so it's a little clearer, easier to see. If I started at the center here, notice that to get from the y value of 1 down to -3, I go down 4 units. And then to get from an x value of -1 to an x value of 4, I technically count to the right 5 units. And since the 4 is going down, it's negative. 5 going to the right, that stays positive. So I put my rise over my run, I get the same value. Okay, so the point is you can get it by counting or you can get it by using the formula. Now that we know the slope of line T, the easiest way, the quickest way to figure out which point is going to be on it is to go ahead and just count. So what I mean by that is start at 4, -3, okay? Then you could go to the right 4 units. Therefore, you would end up with an x-coordinate of 8. And then you could go up 5 units. So -3 plus 5 would put you at a y-coordinate up here of 2. Okay? So this point up here, just moving according to the slope, is going to be 8, 2. Notice that's one of the answer choices. So we have the correct answer. It's going to be letter C. Now, here's an alternate way you could do it. It's a little bit more work, actually a fair amount more work, but if you don't know or not familiar with the counting and moving between the lines, what you could also do is you could say, okay, I know that the slope of this line is 5/4, and I know that a point on this line is 4, -3. So you could go ahead and you could find the y-intercept of the line. So y equals mx plus b. The reason we find the y-intercept is to find the equation of the line, and then once we know the equation of the line, you could easily determine which point is on it. So all we'd have to do is now plug in the slope, 5/4, plug in the x value, plug in the y value, and then solve for b. So if we go ahead and do that, the 4's will cancel out. We should get b equal to, that should be a 5 in the subtraction. It's going to be -8 as the overall value. Okay, b equals -8. So the equation of this line is y equals 5/4 x minus 8. Now what you could do is you could take the x value, plug it in, multiply it out, and see, do I get this corresponding y value for the answer choices? So obviously 5/4 times 8 minus 8. 4 goes into 8 2 times. 5 times 2 is 10. 10 minus 8 is just 2. So when an x is 8, y is equal to 2. That matches answer choice C. If you plug in 9, it's going to come out to some fraction, and it's obviously not going to equal 1. So that's an alternate method you could do if you don't remember, don't know about just, counting according to the slope. All right, next question is a system of linear equations. They only want to know the value of y for this problem. So I'm going to show you, first of all, the very quick and simple, easy way to do this. Even though both of these lines are in standard form, are in slope-intercept form, y equals mx plus b, you can still add them together like you would normally do if they were in standard form. And the reason I would do that is because notice the x variables have opposite coefficients on them, positive 3 and negative 3. So the point is, you can just add these two things together as they're written. You don't have to have the x and the y values on the same side of the equal sign. So if we add the left side, we get 2y. We add the right side, the x's cancel out, and then we get 6 plus 9 is 15. Divide by 2, y equals 7.5. So correct answer is going to be letter B. Now, an alternate way you could do this, if you noticed that since they're both equal to y, like maybe you were taught, maybe you learned then that you would set each of them equal to each other, and then go ahead and solve it out. And you could do that. It's just going to be more work, and I'm just going to demonstrate it right here. So we add 3x to both sides. We subtract 6 on both sides. You get 6x equals 3, or x equals 1/2, or 0.5. Then you go back to one of the original equations to solve for y. I'm going to put it in the top one. Y equals 3 times 1/2 plus 6, or 3/2 plus 6. And you could do it as a fraction. It comes out to 15/2. Or I would just do this on the calculator, and it would come out to the 7.5, because 3/2 is just 1.5. So that's an alternate way to do it. Again, it's more work, but there's nothing mathematically incorrect about doing it using that method. Next question, problem number 22. So here we have basically a problem that we can just solve just by dividing the two numbers that were given. So because essentially they're asking for kind of like the population, they're asking for the population density here, which is gray wolves per square mile. And so they give you the number of gray wolves, they give you the number of square miles. So you don't have to do any unit conversions or anything else. You just divide these two numbers, and then that's it. So if you do this, just on a calculator, it comes out to 0.0376, if you round it off. And which of these answers is that closest to? Well, it's just 0.04. So correct answer is letter A. All right, question number 23. So for this problem, to answer the number of x-intercepts that the graph has, well, that's just basically going to be equal to the number of factors, that has. Because notice this equation, or this function, better word to use, is already factored. So to find the x-intercepts, that's where y value is equal to 0. So if we do that, you have like some of these which have a multiplicity of 2, for example, on the x minus 4, and 3 on the x minus 5. But that doesn't change like how many times that each factor crosses or bounces on the x-axis. So this one is going to be 3. Basically, it's going to be x equals 0. And then, if you set each of them equal to 0, those are going to be your answers. It's going to be x equals 4, and it's going to be x equals 5. Now, an alternate way to do this one, of course, would be to just graph out the function and look at the graph. So I'm going to go ahead and do that. So again, going to the graphing screen. Okay, so we got x times x minus 4 squared times x minus 5 to the third power. It looks like my window is not the standard window because of a previous problem I was doing. So as soon as this graph is done drawing, which we don't really see very much for. Okay, we'll go to zoom. We'll just go to zoom standard to kind of reset it. Okay, so now what we probably need to do is zoom in, maybe somewhere kind of right around in here, like halfway between 0 and 5, since those are the three values that we actually have. Okay, so there's one at 0, and you can see that if you move over, if you trace it right here, or if you go to the table of values. This might actually be the easiest way to see how many there are. Basically, okay, we're up here, like above 10, and the values are extremely large. So let's go back. Okay, so there's 1, 0, or 1 x-intercept. There's a second 0 or second x-intercept. There's a third one. And so that's pretty much it. And you can see here the values, again, get extremely large in the negative direction. So that just confirms that there's 3. Also, you could have technically used the 0 function here, and you could investigate the specific locations where it looks like it crosses, but it's actually probably quicker and easier, again, just to go to the table and scroll through and see how many points are there where there's a y value of 0, which there are 3 of. Okay, next question. Problem number 24. This is basically a statistics, like sample, um, related question. And they're basically asking, what would you change in the experiment, kind of the way it's set up. So the correct answer for this one is going to be B, because if you look at the original way that the study happened, so there were two 500 seed packages, and they were different. The first package had a supplement in the soil, and the second one did not have the supplement. So when the original experiment was done, the 1,000 seeds, like it says, were in a greenhouse, so that the conditions for all seeds were identical. But you can't conclude anything about the supplement because you took all 1,000 seeds and put them in the same conditions. They basically need to be separated and put in, essentially half the seeds from one package in one soil type, half the seeds from the other in the other soil type, and then that would tell you which, how the supplement that was added to the soil would actually affect the growth. In other words, they need to be differentiated in some manner in order to determine how that factor of the supplement, being in the soil, would affect the growth. So the correct answer is going to be letter B. In problem 25, here you have something which is basically just essentially a multiplication question. It looks difficult by the way that's written and some of the terminology they use, but all it's basically saying is you have a sample of this plant, okay? The thing is 12 grams, that is its mass. 0.07% of it is this fatty acid. So if you have a 12-gram sample, what's the actual mass which makes up this specific fatty acid? Well, it's basically asking what is 0.07% of 12 grams? And that's just the same as 0.0007, because, again, converting to a percentage to a decimal, we move the decimal 2 spots to the left, i.e. divide the percentage by 100, and then just multiply that by the 12. And so when you do that, it should come out to 0.0084. And so the correct answer is going to be letter A. And that's it Again, all you're doing is you're finding 7% of, or sorry, excuse me, 0.07% of 12. And then that's your answer. All right, in problem number 26, this is a fairly tricky question. There are two different ways that you can solve it. So the first way I'll go through is kind of go through and explain the theoretical way, and then after that I'll show you how you could use picking numbers to figure it out. So this is an exponential growth function, basically representing population from 1990 to technically it ends up being 2015 because t is less than or equal to 25. 1990 plus 25 is 2015. So now they want to know what would it look like if they want to know what if you wanted to change it so they gave the population after 1995. So essentially what you're kind of doing is you're like shifting it, so to speak. And now you're starting in 1995. So if you think about it, in 1995, okay, which is 5 years after 1990, i.e. t equals 5, if you plug that in, the population would be 1.1 times 1.066 to the fifth power. Okay? So in 1995, that's what your like population would be. So now this is like the starting population for the new function, and then you're going to continue to multiply that by 1.066 for the number raised to the power of the number of years, after 1995. Just like t was functioning here. So the correct answer is going to be letter C. And again, it's kind of like, if you think about this, it's like this is the population in 1995, like your starting point or your initial population, and then this is the exponential growth, after 1995. Now, here's how you could do this using the strategy of picking numbers. So let's say that I let t equal 5. So in other words, I wanted to find the exact population in 1995. So what I would do first is I would plug that into the original expression, so 1.1 times 1.066 to the fifth. I go ahead, I work that out, it comes out to 1.514. Again, these are in millions, but I'm just going to use the actual numbers. I'm not going to worry about the millions, carrying it through. Okay, so now that means for these answer choices, to find the population in 1995, I'm going to let n equal 0 because 1995 is technically 0 years after that year. So I go through all the answer choices, and basically I'm going to plug in 0. So like this whole thing, 5 times 0 is just going to be 0. This is just going to be negative 5. This is going to be to the 0, and then this is also going to be to the 0. So notice for the first one, it's just going to come out to be 1.1 because the 1.066 to the 0 is just 1. So that's obviously wrong. That doesn't match 1.514. For this one, 1.066 is going to be to negative fifth, which means we put a 1 over it to the fifth. So it's going to be wrong. I mean, I'll just tell you it's 0.799 if you work it out on a calculator. C is obviously going to be the correct one. If you work it out, it's 1.514. And then D, if you work it out, it comes out to 2.217. That is wrong. So this is an alternate way you could do this using picking numbers. Again, the strategy would be pick a number for t. It would have to be something 5 to 20 or 5 to 25. Plug that into the original function, calculate the population in that year, and then go through the answer choices, plugging in what the corresponding n value would be, and notice that n is 5 less than t, and then see which value matches what you got in the original function. All right, next up we have question number 27. This one, again, there are multiple ways that you could solve it. So first I'll go through kind of the theoretical way. So here's the theory behind this is basically to have two distinct real solutions. The discriminant, which is the part of the quadratic formula that is under the radical, i.e. the b squared minus 4ac, has to be greater than 0. If it is equal to 0, you have one real solution. If it is less than 0, you have two complex solutions. Therefore, if I plug in the numbers that I know up here, so like A is 1, C we don't know, B is 6, and then I solve this out, it's going to give me the answer. So 36 minus 4C greater than 0, 36 greater than 4C, 9 greater than C, or we can switch it, C less than 9. So correct answer to this is going to be letter D. Here are alternate methods you could use to solve it. You could use the strategy of picking numbers. So let's start with the first answer choice, C equals 6, okay? We get x squared plus 6x plus 6x plus 6. Now, the quick and easy way to solve this would be to use a graphing calculator. So, and what I'm going to do is I'm going to just graph out the function and see how many x-intercepts does it have. Because x-intercepts, roots, zeros, solutions, those are all the same exact thing. First, I will remember, though, to adjust my zoom window. We'll cancel out of that. Okay, so now we've got x squared plus 6x plus 6. And just so you know, there are multiple ways that you could, do this on the calculator, but the quickest way, I think, is just to graph it. So here's the problem. And the first thing, when we let c equal 6, that one works. So that means we have to keep it for now. It also means that technically this one is wrong, and also this one is wrong. Because if it equals 6, it can't be greater than 9. But we have to check it against answer choice D, because it's possible that, like, 6 is not the only value that works. So now that we know it's either 6 or 9, we have to pick another value, basically any number other than 6, which is less than 9, and we see if it works. If it does, it's D. If it doesn't, then it's A. So I'll just change the 6 to a 7. Now I'll graph it out, and I'll see, do I still have two real solutions? Okay, yes, see that I do. One is here and one is here, because there are two x-intercepts, two zeros, which are also two solutions. So therefore, the correct answer for this one is going to be letter D, not letter A. So that's an alternate method you could use to solve this one out, using the graphing calculator. All right, next up, question number 28. So here you're given just a bunch of plots, points, on a graph. They want to know what an appropriate linear model, i.e. best fit line for this is. There are multiple ways you could do this. So the first way, I would say, is you just kind of like draw or sketch an estimate on the thing here. Notice that the y-intercept is going to be something between 0 and 10. So that means we can eliminate C and D, because those y-intercept values of 10 and 90 are way too large based on what we have. So now we have to determine, what's the appropriate slope going to be? So if we just estimate, looking at between two of these points, so here, to get from, this point to this point, we go up 10, so our rise is 10, and then we go to the right, like almost 0.1. And this is where you have to be careful. Notice these are not whole numbers on the graph. I mean, I'll zoom in larger just so you can see them. It's 0.1, 0.2, 0.3, 0.4. Okay, so the distance you move is not 1 in the x value, it's 0.1. So your slope is approximately 10 divided by 0.1, or in other words, it's equal to 100 over 1, or approximately 100. Now, when you look at the answer choices, well, 90 is much closer to 100 than 10 is, so the correct answer is going to be letter A. Now, here is an alternate method where you could use the graphing calculator to figure this out. So what I'm going to do is I'm going to go to the Stat menu. I'm going to go to Edit, and I'm going to put in values for two of the points on this graph. So the first point has an x value of, we're just going to estimate 0.1, and it has a y value of 10. And then the second point So we used this one right here. The second point we're going to look at is this one, x value 0.2, y value of 20. Then once we type those in, we'll go to the stat menu, and then we can go to the linreg function. This will calculate the equation of the line between those 2 points. Now, the equation of the line is not going to match exactly the answers, but we're looking for answer choices that are closest for both the slope and the y-intercept. A is the slope here on the calculator, and B is the y-intercept value. So, it looks like the slope is 100, okay? So obviously this slope of 1.5 is way too low. Get rid of it. And now here with these two choices, which of these is closest to 100? Well, it has to be A, by process of elimination. So again, it confirms A is the correct answer to this problem. Next up for 29, one of the most confusing questions on this test, to be honest with you. The method that I would use to solve this is back solving. Basically what's happening here, okay, so is you have a piece of paper and it's cut twice and it results in 3 smaller pieces of paper the same shape and size. So I'm just going to envision the paper starts out looking like this just to visualize this easier. So then we cut it twice. Okay, and so imagine that these 3 rectangles are all equivalent to each other. Okay, so 2 cuts, so number of cuts, number of pieces. Okay, so we cut it twice, we have 3 pieces. Then we go ahead and we stack like these basically 3 pieces of paper on top of each other. Okay, and we cut them each, we cut 2 more times and it forms 9 total smaller pieces. So we don't need to necessarily visualize this, but what we need to take away is now the total number of pieces we have is 9 and the total cuts we've made is 4. So now we just have to take one of these 2 points and plug them into the answer choices and see which one works out to match the corresponding p-value, or it's technically the f of c value. So I'm going to take this first point. I'm going to plug in 2 for c. So I start with answer choice A. I have 3 to the 2 over 2, which is 3 to the first. That's 3. So far we keep this. We need to see if any of the others give us 3. If not, then it's the correct answer. So for B, I have the same exact thing, except it's now 3 to the 2 over 2, which is 1. Or so now it's 3 to the 3 to the second, 1 plus 1. That's 9. That does not match the p-value we're looking for, so that one's wrong. This one's going to end up being 3 to the 2 times 1, which is 3 squared. It's also 9. It's wrong. This one's going to even be larger than that. It's going to be 3 to the 2 times 1 plus 1, or 3 to the third, which is 27. That one is wrong. So the correct answer choice is letter A. Again, the easiest way to solve this one is once you know how the number of cuts corresponds to the number of pieces, then take the number of cuts, plug that in for C in the answer choices, and then see which one gives you the correct output for the number of pieces. All right, in question number 30, here you basically have a unit conversion type problem. Excuse me. So this one can be done kind of using techniques you might have learned in chemistry if you've taken that. Essentially, it's like dimensional analysis. So it's talking here about a rate, whatever, 1 acre per decade, but they want to convert that rate to number of square kilometers per decade. So I'm going to start with, say, 1 acre per decade. The decade part doesn't matter because we don't have to convert the time, but whatever, I'll just write it here for now. Okay, so what you have to do is basically convert acres to square miles, and then square miles to square kilometers. So what we could do now is we could write 640 acres. We're going to put that on the bottom because we want the acres to cancel out to 1 square mile. Okay, that's a unit conversion they give us in the problem right here. Then what we're going to do is going to go ahead and multiply by the other conversion they give us, which is now 1 mile is equal to 1 kilometer. The problem is, okay, acres and square miles are both units of area. In other words, they're two dimensions. But a mile and a kilometer, this conversion factor is one dimensional. A mile is just one dimension, kilometer is one dimension. So what you have to do now is you either have to multiply, and it should be 0.62 miles on the bottom, not 1. Down here, 0.62 miles. Okay. Now what you have to do is you have to multiply by this again, or you have to square this conversion factor. And that's what will turn it into square miles on the bottom and square kilometers on the top, because you want your final answer to be in square kilometers. So now what ends up happening is acres and acres cancel out. When you square this, now the square miles will cancel out and you'll be left with square kilometers. And now you just multiply through. So on the top, it's 1 times 1 times 1. On the bottom, it's basically 1 times 640 times 0.62 squared. So let's see. On the bottom, it's going to be, you could do the entire multiplication out, just as one step. But I'll just show you what you should technically get for the fraction before you divide it. It should be 640, and then you're going to multiply it by 0.62 twice. So it's like 246.016 approximately, and then we do 1 divided by that. And so what ends up happening for our answer, it's going to be 0.004064. So when we look at the answer choices, which of those is closest to it? Well, it's going to be this last one, letter D. This just rounds off to approximately 0.0041 square kilometers. All right, now starting with the grid-in questions. Number 31. This is just a very basic, easy reading a graph type question. How many paddle boats were on the lake at 2 p.m.? Well, we go to 2 p.m., we go up to this point right here. We notice that corresponds to a y value of 7, so the correct answer to this question is just 7. That's what you grid in. No other work is required. Okay, for problem number 32, here you have a company spending $9,000 on digital and print ads, and the ratio of the money spent on digital to money spent on print was 1 to 3. How much money did they spend on digital ads? So you could technically set this one up as a system of linear equations, but you actually don't need to do that. You can actually just set it up as one basic equation to start. So we know our total spend is $9,000. And we know that the ratio on digital ads to print ads was 1 to 3. So 1 to 3, and then we can just use x as like our common, amount, which would then get multiplied by 1 or by 3 to end up making our total. So this is basically digital. This is print. We're going to go ahead, solve this equation out, get the value of x, and then that technically would be equal to the amount we spent on digital because it's just multiplied by 1. So 4x is equal to 9,000. You divide that on your calculator, you should get 2250. So again, to find the digital amount spent, because that's all they want, it would just be this 2250 number. That's what you grid in. That's what the final correct answer is. Next up, problem number 33. Here you have a quadratic equation that does not factor, and they are giving the solution in basically like kind of a different form than we're used to. It's basically kind of like a modified quadratic formula, so to speak. So what I'm going to do is go ahead, I'm going to solve this problem out just using quadratic formula, and then show how we simplify it to get into this format that they're looking for. So we know a is 1, b is 2, c is -1. Once we have all that, then we can just go ahead and plug it in. So we've got the opposite of b, which is -2, plus or minus b squared, which is 2 squared, minus 4 times 1 times negative 1, extend the square root over 2 times 1. So we got negative 2, positive 2 on the bottom, plus or minus. Under the radical, it's going to be 4, and then the two negatives make it plus, so it's 4 plus 4, which is 8. Now we will simplify square root of 8 into 2 root 2, and that's all over 2. Now at this point, you can cancel out the following 2's. The bottom, the 2 in front, and the 2 in front. You do not touch the 2 inside the radical. It's only the 2's that are outside the radical that get canceled. So now this is equal to negative 1 plus or minus root 2, because it's all over 1 in the bottom, so we don't need the denominator. And now it's going to be equal to the form that we're looking at up here. It's basically plus or minus square root 2 minus 1 if I just switch the order of the terms. So what's the value of k? Well, k is equal to positive 2. So the correct answer, what you grid in for this problem, is just positive 2. Next up, 34. Here we have a question that gives you the equation between how to convert between basically temperature in Fahrenheit to corresponding temperature in Celsius. And so, okay, it tells us that the temperature increased by 19.8 degrees in Fahrenheit. How much did it increase in Celsius? So first I'll show the very kind of like theoretical, quick and easy theoretical way you get the answer. So whenever you're talking about with a linear equation, which is what we have here, whenever you're talking about the change, in something, in other words, this thing increased or decreased by this much, what was the corresponding, change in the output value, or essentially in the y value? All you're doing is taking the slope and multiplying it by the change in the x. So in other words, you take 5/9, you multiply it by the change in x, which is 19.8. You do that on a calculator, it comes out to exactly 11, and that is technically the answer. Now, if you didn't recognize that, then that's totally fine. Then I would pick two numbers, and I would use that strategy to go ahead and figure it out. So for my two values, I'm going to pick 32 as like my start, and then for my end, well, I'm just going to add the 19.8 to that and use 51.8. The reason I chose 32 to start is because when I go to calculate it, it's actually going to be very easy because I plug in 32 for x. 32 minus 32 is 0. This whole thing is 0. So my starting temperature for Celsius is 0. These are Fahrenheit values and so on. Okay. So now I'm just going to go through and I'm going to plug in the 51.8. And then whatever I get for my output or my answer, like since I'm just subtracting 0 from it, like that's going to be the change in the temperature in Celsius, in degrees Celsius. So you do 5/9, so 19.8 minus 32, well that's just, 51.8 minus 32 is 19.8. Then you multiply that by 5/9. I already did that, initially in the first method going through the problem, and you get 11. So now 11 minus 0 is obviously 11. That's an alternate way to think about the problem or attack the problem if you don't recognize that really all you have to do is take this change and multiply it by the slope. Okay, next up, question number 35. This problem is a probability question along with a little just basic area calculation for rectangles. So the probability that the point's going to be within the shaded region is going to be equal to the area of the shaded over the area of the entire, large rectangle. So the large rectangular area is just going to be 5 times 7, which is 35. The shaded area is technically like the area of the large, or the area of the entire rectangle, minus the area of the white. So in other words, we're going to have 35 minus 3 times 5, 15, and then that goes over 35. So we get 20 over 35. And now that's not our final answer because we do want to reduce it. So these each have a common factor of 4. Divide 20 by 4 and get 5. Divide 35 by, not 4, excuse me. They have a common factor of 5, and that's going to reduce the 20 to a 4 and the 35 to a 7. So you could grid in 4 divided by 7. You could also grid in the decimal equivalent, which would be 0.571. So either of those are correct for this problem. Now for 36, here you have a linear equation, and they're asking what's the value of q if this equation has no solution. So hopefully hope you recognize that for an equation to have no solution, a linear equation, all the x variables must cancel out, or the x terms must cancel out, and therefore be left with like 0x. So in other words, negative 9x plus 24qx must equal 0. Or, really, we're only concerned with the number values. So negative 9 plus 24q has to equal 0. If you solve this for q, you get 24q equals 9. Divide by 24. Q equals 9 over 24, which reduces to 3 over 8. So you could grid in 3/8, or you could also grid in the decimal equivalent of 0.375. So either of those would be correct. And you can check if you plug in 3/8 up here and then multiply it by 24, you get negative 9x plus 9x equals 36. 0 equals 36. There's no solution to that equation. Let's see. Last we have 30, or not last, next to last, we have 37. So this problem, there are multiple ways to think about it. Again, this is a tricky problem just because of how it's worded, not necessarily in terms of the actual difficulty in calculating it. So it tells us that r is equal to 20 over 21 times t. And then it says the value of t is what percent greater than r. So if you take this and you rearrange it, say multiply both sides by 21, and then divide by 20, you get t equals 21 over 20r. Or if you write that as a decimal, t equals 1.05r. And now if you think back to well, I guess let's think about it this way. So let's say r is now equal to 1. So if I plug that in, then 1.05 times 1, that means that t would be equal to 1.05. So now it says t is what percent greater than the value of r. So to find the percentage change, that's what we were doing when it says something is what percent greater than something else. You do new minus old divided by old. And then, of course, times 100%. But here we don't want, we're not going to enter the percent sign, but we do need to multiply it by 100. So our new is 1.05. Our old was 1, or yeah, the original. Divide that by 1. So we get 0.05 divided by 1, which is just 0.05. Multiply that by the 100. So you get 5%. Again, you don't enter the percent sign, so the correct answer to this question is 5. In other words, the value of t is 5% more than the value of r. Now, another way you could have looked at this or figured this out without actually going through and calculating the percent change and all that stuff that I did is, it's like if you go back to here where you where I rearranged it and had it set up like this, this is basically like think about how an exponential growth function works, where it's like 1 plus or minus, if it's minus for decay, but for growth it's 1 plus or minus r, and then whatever, it's raised to some exponent. The point is, if you take this 1.05 and you think of it or split it up into 1.05, that's how you can see or visualize, and then you multiply it out. Notice you would get r plus 0.05r equals t. And so it's this extra thing right here that's the 5%. That's the 5% greater that t is than just r itself. So that's kind of like the theoretical explanation behind it. Now we are at the last question, 38. Again, this one is a confusing one just because of how it's worded. There is a little work you have to do with exponents and stuff according to the math, but basically what you have going on here is you have 4 times the square root of a is equal to 9 times cube root b, okay? First thing I'm going to do before I plug anything in is I'm going to rewrite these with rational exponents. Okay, now I'm going to plug in also 2/3 for a. So again, all I've done so far is I set up the equation based on what they told us. I went ahead and I plugged in the value for a that it's equal to, and I rewrote the radicals as fractional or rational exponents. And now it says, okay, what value of x is a to the x equal to b? What that means is solve this equation, or rather rearrange this equation for a, or which is really 2/3, and then what you get on the other side is going to end up being what b is equal to. Or excuse me, I have that backwards. They want to know what's equal to b. We want to solve this for b. In other words, we want to get b alone by itself, and then whatever number we end up with, really for the exponent on the other side, is what we're going to put down as our answer. So we need to solve this for b. First step I would do is divide by 9. So now notice on the left side you have one fraction is 4/9 and one is 2/3. But what you can do is I can take the 4/9 and I can rewrite it as 2/3 to the second power. And now, technically what I could do is, since I have the same base, I could multiply these, and I could turn this into 2/3, and now I add the exponents, 2 plus 1/2. That's going to turn out to be 5/2, or 2.5. Again, do that on your calculator if you're not confident with it or not sure of it. Just add 2 plus 1/2, and then you should get 5/2, or it'll give you 2.5, and then just do the math fraction to convert it to 5/2. Okay, and that's equal to b to the 1/3 power. So now all we have to do is just cube both sides. So raise both sides to the third power. That leaves b alone by itself. And then on the left side, what you could do is then just do 5/2 being raised to the third is the same as 5/2 times 3, because you multiply these two exponents because we're raising to a power. So we get 2/3 to the 15/2. And again, remember, a is equal to 2/3. So now you could just technically go ahead and replace this with a if you wanted to. So a to the x is equal to b. So what does x have to equal up here? Well, it's 15 divided by 2. So you could put that as your answer, or you could also write the decimal equivalent of 7.5. Okay, so however you want to do it, that's how you solve, this last question. It's a little tricky, especially with dealing with all the fractional exponents, and recognize that you have to take the 4/9 out front and turn that into 2/3 quantity squared. But it's actually not that bad of a problem in terms of the actual, amount of work required. So those were all the answers to the calculator section of the October 2022 SAT QAS. If you have any questions or comments, please leave them below this video. Also, if you haven't done so, check out the answers to the no calculator section, which were posted previously. And of course, if you like this video, please click the thumbs up and sign up to subscribe to my channel and for notifications as well.